All right, so today we're going to just solve right triangles, which you've done since geometry. Brian, unplug. And it's okay. I know. And we're going to also talk about bearings, which when we talk about bearings now, it's like an introduction to what we're going to do in chapter 6. Okay, so next semester. All right, so it's just an intro right now. I'm assuming you remember how to solve a right triangle. You know, you can use things like the facts that you learned in geometry. There's 180 degrees in a triangle. You can use Pythagorean theorem. You can use your trig functions, you know, SOHCAHTOA. You can also use the facts that you know, like for example, if you have the largest angles across from the longest side, right? And the smallest angle is across from the shortest side. So all of these things are going to come into play, and let's just solve a right triangle real quickly, okay? First thing is you're going to draw a picture. So based on this, they've given us some information, right? We know that angle C is our 90-degree angle. Angle A is 36 degrees. And side C is 15. And remember that side C is across from angle C. So this is 15. Okay, so now anytime you do this, which we will also be solving some more triangles in chapter 6, anytime that you do this, I expect you to give me a labeled picture, and then I also want an area for your answers. So I want you just to list out everything you have to find. So we have to find the measure of angle B, we have to find side B, and we have to find side A. Also remember from geometry that an angle is denoted by a capital letter and a side is lowercase. You remember all those facts? Okay, great. So the easiest thing to find first is the angle, right? We know that there's 180 degrees in the triangle. We've been given 90 and 36. If we take that away from 180 degrees, we know the other angle measures 54. Okay, don't forget, anytime you're giving an angle measure, you have to use the degree symbol. Okay, so now here's my recommendation. Anytime that you have to find side lengths, only use the information that's been given. Like, don't use this 54 degrees. Even though we know how to subtract, if you made a mistake, that's going to throw every answer off, okay? So just use the given information. So based on that, what do we have here? Think about SOHCAHTOA, right? If we have this angle, isn't this the opposite, this the adjacent, and this the hypotenuse? Right, so we know the hypotenuse, we can find the opposite and adjacent using sine and cosine. Doesn't matter which one you find first, it's your choice. Is it okay if we go with A first? Okay, so we're going to do the sine of 36 degrees equals A over the hypotenuse, which is 15. Right, and remember that this is just a proportion. It's really like the sine of 36 degrees is over 1, and all you have to do is cross multiply. So we get A equals 15 times the sine of 36 degrees. Now, when you enter this into the calculator, what mode do you have to be in? Degree mode, very good. So let's change our mode. All right, and then 15 sine of 36. 8.817. Everybody agree with that? Okay, so over here, 8.817. So this is like our answer box, okay, and I'm going to be looking for that every time. Okay, so now again, we don't want to use this 54 degrees or this 8.1 or 8.817. We want to use just this given information. So going back, now we can use cosine. So I'm going to have the cosine of 36 degrees equals B over 15. Same deal, we're going to cross multiply. All right, type that in, see what you get. Did you get 12.135? Okay, now you're going to take a second and you're going to look at your answers and you're going to ask yourself, do they make sense? Does it make sense that side A is the smallest side? Yeah, because it's across from the smallest angle, right? Does it make sense that B is in the middle? Yes, because 54 degrees is between 36 and 90 degrees. Okay, so just do a quick check of your answers. Make sure they make sense. Everybody comfortable with solving a triangle? Moving on. Okay, so you are going to have to remember the angle of depression and the angle of elevation. Do you remember those? Or should we go back over them? Real quick? Okay, so angle of depression is the harder one, right? So that's like, remember my bird thing? The bird's in the tree and he's looking down at me. Remember that? Of course you do. So the bird's line of sight is here. When it looks down, this creates the angle of depression. Normally, that is outside of the triangle that we need, right? So here we create this 90-degree triangle, and you can just subtract it from 90. These angles are complementary. So to get the angle inside, you just subtract 90 minus the angle of depression. Or you can use what you know from geometry, which is that these are alternate interior angles, and these two angles are congruent. So just keep in mind, if you're given the angle of depression, it's outside of the triangle, and then you need to manipulate some things to figure out what's on the inside. Okay? Everybody okay with that? Remember, angle of elevation is where you are looking up at the bird. This is a tree. And you are looking up at it. So from the ground up is your angle of elevation. Okay? So that's inside the triangle. That one is easier. You don't have to do anything else for it. Okay, remember those? All right. Well, let's take a look. It says you will use two right triangles to solve for S. All right, so just take a look at this picture here for a second. Okay, we're trying to find S. How are we going to do it? Noah?
First you get the angle of the last angle of the first triangle.
This here?
Well, you can do that.
This here.
Well, that's 35 degrees.
Okay.
Well, then the other one,
Okay.
like way on top.
So this one?
No.
This one?
No.
This one?
Yeah.
Okay.
You find that, and then you can subtract that from 180 to get that other angle, and then you can get the other angle on top.
Okay, but I want to know the side. This is a side length. So I really don't need the angle.
Gotcha.
I have enough information to actually start solving, but it is a lengthy process. What would I have to do first? Ryan?
Find the angle measure of like the top one.
So that was Noah's suggestion, right? Is start over here. We really don't need the angles. We have enough. Arwa? Okay. Okay, so you could separate the triangles and create a proportion. There is an easier way. Jake, you said something. So if I find A first, how does that help me? No, it's good. We got to do that. Sure. So we're going to find A, but we have to do something else after we do A. Do you agree that there really are two right triangles going on here, right? There is a large one. Let's separate it. So there's this large triangle, and its angle is 53 degrees. And what is its side length here? Yes, S plus A. Okay, then we have a smaller triangle. This is 35 degrees. And this side length is just A, right? So, how do I find just S? Yeah, if I find A and I find S plus A, can I just subtract it and find the difference? Good, okay? So I want to find A, then I want to find A plus S, then step 3, I want to subtract 2 minus 1. Step 2 minus step 1. Does that make sense? Okay, so let's go ahead and do that. So now, based on these triangles here, oh, this was 200 feet. We never wrote that down. That's important. Okay, so based on that, can't we use right triangle trig here? Okay, so I'm going to have the opposite over the adjacent, so I'm going to use tangent. So I have the tangent of 35 degrees equals A over 200. Step 3 is subtract your answers from step 2 minus step 1. Okay. So go ahead and put that in the calculator. What did you get?
140.042.
Yeah, 140.042. I also got that. Keep in mind that this is a situation where we have units, so our final answer is going to have some units on it, okay? Now we want to find A plus S, so we want to find the entire length of this side. Don't we do it the exact same way, except this time we use 53 degrees? Okay, so I'm going to do the tangent of 53 degrees equals A over 200. Okay, did you get 265.409? Okay, and now all we have to do is subtract those, right? So we're going to take that 265.049 and subtract, whoops, 409 that was, and subtract 140.042. I got 125.367. Can I get some confirmation on that? Good answer. And then this would be in feet. Okay. Does that make sense? Okay, so a three-step process. Finding the smaller side, finding the entire side, and then subtracting the difference. Okay? Yes?
So that tangent of 53 is equal to 8 plus or
Yes, that's representing, really it shouldn't say, yeah. This is technically A plus S in the numerator there, which represents that side. You could call it X too if you wanted. Can we shift gears into bearings? Okay, so now this is kind of the second part of the lesson. And we're going to talk about bearings. And again, this is going to come up again later on in the year in Chapter 6. So bearings are just used in really navigation. A lot of ships and planes use this, and it's really just a way to talk about direction. Okay? So a bearing gives a direction and it also gives an angle. So you have to think about the compass when you do this. We're going to draw these bearings. Okay, so I just want you to watch me draw this first one, and I think it's going to be pretty easy for you. So you want to think about a compass first, right? So we have north, east, south, and west. And you really just follow it in the order that it states. So you always do the north or the south direction first, okay? So that's going to be north, so we're going towards the north, 32 degrees east. So I go towards the north, and then I turn 32 degrees towards the east. So you have to imagine 32 degrees, and which way is east? Do I go right or do I go left? Right. So I turn about 32 degrees to the east, and that is my bearing, where this angle here is my 32 degrees. Okay, so you go north or south first, you turn towards the direction that it states, and then you draw your angle. Yes?
So would you go 32 degrees from the north point?
Right, from the north direction. Okay, so let's try B. So now we're going south, 14 degrees west, so you just read it in order, okay? So I'm going south, so I go down first, and then 14 degrees to the west. Am I going left or right? Left, and then I just imagine 14 degrees. So this is my 14 degree angle. Okay? You try C. Do you have what I have? You go south first, you turn towards the east, which is turning towards the right, and you go about 68 degrees. Pretty easy? Everybody comfortable with a bearing? Okay, so there's not going to be questions like this on your quiz. Okay, draw a bearing of north 14 degrees east. That's a little too easy. But we're going to incorporate this idea into a story problem because this is pre-calc, right? That's what we do. So let's go ahead and try that. So we're going to sketch a picture. For any story problem, you have to sketch a picture for me. Okay, I will be grading your picture. It's part of the problem. Okay. So a ship is 32 miles east and 20 miles north of port. What is the bearing back to the port? Okay, so here's what we want to do. We want to draw our picture first. Okay, so let's just choose a point anywhere for our port. So I'm going to put it here. And I'm going to label it port. Because that makes sense. Okay? Now we have to go 32 degrees, or 32 miles to the east. So should I go left or should I go right? Right. So now I'm 32 miles to the east, and I'm 20 miles north. So I should go up 20 miles. Try to draw your picture, you know, kind of to scale. It really helps when you're trying to find some of these answers, okay? So at this point, here's my ship. Okay, there's my ship. It's like a little sailboat. I was an artist before I became a math teacher. I know that was obvious to you, but... Okay, so now, here's the deal. We have to find the bearing back, okay? So what you're going to imagine is your compass now, okay? So imagine a compass being at our ship, okay? So here's our compass, north, east, south, and west. First thing we're going to do is we're going to decide on a direction, okay? So if I want to take this ship and I want to go back to the port, do I have to go north or south? South. So I know that my answer is going to start with south. I'm going to have some degree measure, right? So I got to figure out the angle. And now am I going east or west? West. So I definitely know the direction. Now I just have to find the angle. So now I want you to think about this. Can everybody see that this forms a right triangle? Right? And that from the south, turning this way, is the angle I actually need, and it's the angle within the triangle. Everybody agree that this is the angle, this is the bearing, right? When you're in the south and you're turning towards the west. So this is what I want to find. This is my theta, okay? Or x, whatever you want to call it. So now, how do I do this? So I got to solve for theta. So I'm having to find an angle. Therefore, I'm going to use the inverse trig functions, right? Like all of this is coming together from 4-7 now. We're using the arc tangent in this case. Agree? So you don't have to really write arc tangent in your problem. You can just write the tangent of theta equals the opposite 32 over the adjacent of 20. Now we did this before and you've done this in geometry. This is the same idea as if I was to take the arc tangent of both sides, which was a homework question last night about putting something in terms of theta. Once you were here, all you had to do was take the arc tangent of both sides. So you would have theta equals arc tangent of 32 over 20, okay? That's really what you're doing there. I don't care to see this. It's not necessary, okay? All you have to do at this point is put this in your calculator, right? We're looking for a degree measure, so we want to be in degree mode. Keep in mind that we're looking for an angle, so we have to use the inverse key on the calculator. So second tangent, 32 divided by 20, 57.995. And that's my angle. Okay, that's my bearing. So I'm going south, 57.995 degrees west. How do I know to put the angle in the middle, you mean? Because it always goes in the middle. Anytime you have a bearing, you go the north or the south, then the angle measure, and then your east or west direction. Okay, every time. Any questions on that problem? I don't care if you, whatever you write here, as long as I see some type of work with that proportion. Okay? Ready to try the next one? Okay, this is our last one. You guys realize this is our last problem in the notes for the semester. This is it, right here, right now.
Take a little longer.
Take a minute, and take that in for a second. We're halfway through the year, kids. Almost there. Okay. A plane is flying. All my subscribers, all 16 of them, are going to be like, what is she talking about? Kidding. Okay, so a plane, no, seriously. A plane is flying at 160 miles per hour and has a bearing of north 18 degrees west. After flying for an hour and a half, how far north and west is the plane from the original position? So here, you're looking for side lengths. We're no longer looking for a bearing. We've been given the bearing. Okay, so we have to draw the picture. So what we're going to do is we're going to pick a point to start with. Okay, so pick a point somewhere. And now we're going to draw the situation. So here's the airport. Okay, this is like the plane taking off, right? So when it took off, it flew at a bearing, and draw on your little compass, okay, because it helps to see it, to visualize it. So it flew at a bearing of north 18 degrees west. Go towards the north, turn 18 degrees to the west, and then we're going to fly. So this is 18 degrees here. Let me kind of zoom in here for you. Okay, that's more helpful. Okay, now it says that the plane flew at 160 miles per hour. But it flew for an hour and a half. So, don't I know this side length here? What is that? Why is it 240 and not 160? Right, because it flew for the hour and a half. So after an hour it went 160 miles, but then it went another half. So 240 miles is this distance here. The question says, how far north and west is the plane from its original airport? So, isn't this how far north it is? Let's call it X. And isn't this how far west it is? Let's call it Y. Didn't this just form a right triangle here? Okay, are you with me? Now, this 18 degrees is not inside the triangle, right? I really need an angle inside the triangle. Is there a way to get one? There's two ways, actually, right? Alyssa?
Isn't it at the top of the triangle? 'Cause it's like, they're the same.
Yes, so there is one option. This angle and this angle here are alternate interior angles. So they are congruent. And that is going to be a huge, huge advantage to you to see those come chapter 6. Okay, so we want to start trying to look for those alternate interior angles. So that would be a great angle to use. Is there another angle I could use? Right. So this also forms a 90-degree angle here, right? Because it's a compass, and north and west come together at a 90-degree angle. So you could do the complement of it. So 90 minus 18 giving you 72 degrees. Okay? So you could use either one of those. It's your choice. Which one you want to use? 18 or 72? I don't care. 18 it is. Okay, so now I'm going to redraw this because sometimes these pictures get a little bit congested. So this is 18 degrees. I need X and Y, and this is 240. Okay? Whoa, you can't see it. There we go. So now I just have to find X and Y. All right, well, to do that, can I just use sine and cosine? Okay, so the sine of 18 degrees equals Y over 240. And then I can also use the cosine of 18 degrees equals X over 240. So we're going to cross multiply, we're going to put it in our calculator, we're going to be in degree mode. Everybody comfortable with all that? For Y, what did you get? Did you get 74.164? And for X, did you get 228.254? Now, are these my final answers? No, because this was a story problem, right? This was a word problem. We need to give a word answer. So this is 74.164 miles to the west. And this is 228.254 miles to the east. What did I do? Oh, not to the east, to the what? North. Sorry, I got so excited it was done. Okay. Good?